In order to divide two complex numbers, we're going to multiply that quotient by a well-chosen one in the form of the conjugate of the denominator over itself. When we divide two complex numbers, the result is again going to be a number. But we want to write this quotient in the standard form of a complex number, which means that we want to write it in a+bi form. And that means that the I that's currently in the denominator has to go. So essentially what we need to do is change the form of this number, but not the number's value. And in order to do that, what we'll do is we'll multiply by what I'll call a well-chosen one. Multiplying any number by 1 does not change its value, but the one that we're going to choose is going to be the one that's in the form of the conjugate of the denominator over itself. So the conjugate of the denominator is 1 plus I, but I have to multiply that in the top and in the bottom to ensure that I am not changing the value of the complex number that we've started with. So let's multiply. Starting in the denominator, notice that we have a complex number and its conjugate, and when I multiply these two together, we could FOIL it, or we could notice that it's the difference of squares in its factored form. In part A, we'll go ahead and FOIL it, and in part B, we'll use the difference of squares formula. So to FOIL, we multiply the first terms together to get positive 1, the outer terms together to get plus I, multiplying the inner terms together, we get minus I, and then when we multiply the last two terms together, we get minus I squared. Now let's multiply the top two complex numbers together, and up here we actually have to FOIL because there's no special case to be employed here. So again, we multiply the first two terms together to get 2. Outer gives us plus 2i. Multiply the inner two terms, we get plus 3i. And multiplying the last terms together, we get plus 3i squared. Now notice here in the denominator that minus I and plus I cancel each other out. So the denominator simplifies to being 1 minus I squared, which is the difference of squares. And we could have jumped straight from here to this difference of squares if we had recognized that factorization. Let's combine like terms in the top. We have 2i plus 3i is 5i. So in the top we have 2 plus 5i. Now we have plus 3i squared, but let's recall that I squared is equal to -1, and anytime an I squared pops up in our computation, we want to remove the I squared, leaving a vacant hole where it used to be, and replace I squared with -1, which is its real number equivalent. So now let's wrap this around to the next line and clean it up a little bit. Notice we also have an I squared down here in the denominator we need to substitute. So we have 2 plus 5i minus 3 in the top, and then 1 minus this I squared becomes a whole, and we replace it with -1. Continuing to simplify, we have 2 minus 3, which is -1 in the top, plus 5i. And in the bottom now we have 1 plus 1, which is positive 2 in the denominator. We're very close now, but we still need to express this in standard form, which is a real number plus or minus a real number multiple of I. So that means we actually need to split this numerator and give each element of the numerator the denominator of 2, so that I have a fraction, which is a real number, plus or minus a fraction multiple of I, and now it's officially in the standard form. Let's do this again for part B. Again, we're going to multiply by a well-chosen one, and the one that we choose is going to be in the shape of the conjugate of the denominator. So this will be 5 plus 3i over 5 plus 3i. Again, this that we're multiplying by does have a value of 1, so when we multiply this quantity by 1, we're not changing its value, but we will change its form into being the standard form. This time, let's notice that what we have down here is the difference of two things squared in its factored form. So when we multiply these two things together, we'll get back to that difference of squares. So the product is going to look like squaring the first term minus squaring the entire second term, which will be 9i squared. So noticing that this is the difference of squares in its factored form gives us a little bit of a shortcut when coming up with its product. In the numerator, we'll need to distribute this 4 into the parentheses. So we have 4 times 5 is 20, and then distributing 4 to the 3i, we'll get 12i. Now again, we're going to replace any I squareds with -1. So that means we'll remove this I squared, it'll become a whole, and then we'll plug -1 into that whole. So we have 20 plus 12i in the numerator. And then in the denominator, we have 25 minus 9i squared becomes a whole, and we plug -1 into that spot. Continuing to simplify, we have 20 plus 12i in the numerator, and then 25 plus 9 in the denominator, which is then 34. And the last thing that we need to do to write this in the standard form of a complex number is to split the numerator and give each element in the numerator a denominator of 34. So we have 20 divided by 34 plus 12i divided by 34, and then we reduce each of these fractions individually. 20 and 34 share a factor of 2, so we factor a 2 out of 20. 20 divided by that common factor of 2 is 10. 34 divided by 2 is 17. We'll do the same thing here for the second term. We have 12 divided by 2 is 6, and 34 divided by 2 is 17. So now we have 10 divided by 17 plus 6 divided by 17, which is the multiple on I, and we have a real number plus or minus a real number multiple of I as the quotient or the result of dividing these two complex numbers.